Hello, welcome to tutorial on homework 3 for MGQ 201. I'm going to go ahead and just open up question 1. Again, it may be a little bit different in your homework. For example, you may have your question 1 may not be the same as my question 1 content-wise, but we will all work on the same problems overall. They'll just be numbered differently. And of course, you'll have different data. Okay, so here we're working on descriptive statistics, and what we're going to do here is grab the data. I'm going to copy it to my clipboard, Control C, and here I'll just label my worksheet. Let's close this out, and first let's calculate the mean. Equals average of, oops. Okay, so just take a look at what the formula is here. Type it in. You can actually also do your analysis tool pack. I'll show you how to do that after here, and that will give you all your descriptive statistics. What I'm going to do here, though, is the median. So equals median. Again, I can put, obviously, these formulas anywhere. I'm just choosing. Oh, here it says do not round. So make sure that you're going ahead and putting it into the decimal places. We're going to look at the modes. Here, because it's such a small data set, I can just kind of see it looks like 18 is appearing twice. So again, the most commonly occurring number, or frequently occurring value. We've got 5 and looks like 18 appearing twice. So if we want to look at what the multiple modes are, we have to actually do an array function. So in order to do the array function, if you recall, we have to select a certain number of cells and then put in the function, and in order to get it to run, hit Shift Control Enter. Multiple modes, I'm just going to go ahead and select this. I don't know how many there are. Obviously there's not, 6 modes, but mode here, I'm going to say mode multi and select the data. And what I'm going to actually do here, close the parentheses, Shift Control Enter, and that shows me I have 2 modes, 5 and 18, and I just selected more cells than I needed, and this is just saying there's not a 3rd mode, a 4th, a 5th, or a 6th mode. So I can go ahead and put in 5 and 18, and it tells me to use a comma to separate those answers. Check. Great. If on the other hand there was no mode, so if there was no value that occurred more than one time, you would go ahead and select no mode in this data set. And the shape of the distribution, we are taking a look at the median and the mean. Okay, so if these are really close and have the same value, we would assume that it's a normal distribution. Here, though, it is less than, the mean is less than, it's going to be a left skew. Good. Okay, on to our next question. 3.1.7. Here, I'm just going to go grab these and Control C, put it there. Perfect. Alright, so in order to grab the average number of laptops here, what we end up having to do is multiply each of the values of x by its frequency. So this is going to be x times f of x. I'm going to set this up so that when I drag it down, it's doing it for each of the respective cells. Okay, so here you see it's A3 times B3, and that's because I made this first formula, a relative reference, and then I can drag it down. I'm going to sum this up. Then what we end up having to do is divide it by the frequencies. So the average number of laptops sold per day in this problem is 1.72. Now we have a problem that gives us two different exchange rates across country or currency A and B for 14 months. So what we're going to do here is calculate the mean. Oh, I didn't show you how to do the analysis toolpack. If I wanted to, if you go into data, you'll see mine has a data analysis here. You probably will not see that, so go into File, Options, Add-ins, and you will see Analysis Toolpack here. If you click on this, and hit go. Mine is enabled, so go ahead and enable yours, and then hit OK. And then what you should see is this data analysis. So actually, this gives us a couple different sort of quick options. And what I can do here is hit descriptive statistics, and the input range is going to be right here. Sorry, I didn't. Summary statistics is what I need to select there. It's going to give me it in a new worksheet, and so here I see the mean, standard error, standard deviation, the median, the mode. We'll talk a little bit more about standard error in forthcoming chapters. But for now, that's going to give me the same values as the formulas. 3 places. 2, 9. The median. Oh, the nearest cent. Okay. And determine the mode. In this case, it's 0.59 it's telling me. I don't know actually if these descriptive functions will give you the multiple modes. Here that would matter, but if there's multiple modes there, I'm not sure how the analysis toolpack handles that. Okay. Which is going to be the best indicator of the central tendency, mean, median, or mode. In this case, it looks as though there are no real outliers. So we could kind of look at is both the mean and the median would probably be pretty accurate indices. Even though the median is a little bit smaller than the mean, meaning that it may not necessarily be very normal, both would be good indicators. Okay, let's go ahead and continue. And the shape, again, because the mean is greater than, it would be a right skew. Alright, let's grab this data. We're going to look at these population values. Copy, paste in. And the range here, again, we could go ahead and do our analysis toolpack. I'm going to actually just do it in terms of just showing you. So the max here value is 29, or 39, excuse me. Whereas the minimum value is, negative 13. So in order to get our range, we have to take the maximum minus the minimum. So the range here is going to be 52. Now the variance, it's telling me this is a population value. So recall that the variance formula is different dependent on whether or not we're using the population or the sample. So to get the variance of the population, it's that var.p and it's asking me to round to 2 decimal places, 321.58. And let's grab the standard deviation. I can do this in a couple of different ways. I could simply take the square root of the variance, or I could also directly ask Excel what the standard deviation of this population of values is. So that gives me the same exact value. 17.93. Check. Great. Okay, let's consider these 2 sample data sets, and what we're going to do here is take a look at the coefficient of variation for both data sets. So the average here and here, and the standard deviation. Now, in order to say, well, do I use the population or the sample formula? It tells you right here, the 2 sample data sets. So equals standard deviation of the sample here and here. And so the coefficient of variation is the standard deviation divided by the mean. So there's a 47% variation here and 54% here. So in set 1, round to 1 decimal place, 47.1. And in sample data set 2, 54.5. And data set 2 has more variability because that coefficient of variation is higher. Let's go on to the next one. Consider the following data set. That is sample. Copy this to the clipboard. Put it in. Done. Okay, so we're going to calculate the z-score for the following values. Recall that the z-score formula is the mean. I'll just put it in here. Z equals the mean. The x value in this case. Okay. Let's calculate the z-scores. In order to have the z-scores, we need our x values. These are our x values here. We also need the mean and the standard deviations of the sample. So because it's each of the x values, in order to get the z-score, x value minus the mean and divide that by the standard deviation, in this case of the sample. So let's get the mean equal average here, and let's get the standard deviation of this sample. Okay. So what we need to do here in order to get the z is take each x value, subtract out the mean, and then divide by the standard deviation. So I just create a formula that does that. Equals this. And what I'm going to do here is reference this value absolutely. So I hit that F4 and it immediately gives me that as a fixed or absolute reference. And this standard deviation I also want to be referenced absolutely. Okay. Another way that we can do this once we have our mean and our standard deviation calculated is simply standardize the x value based on a mean, in this case here, and a standard deviation here. gives me the same exact value. Just a different formula. Oh, in this case, so check it out. I had only placed this as a absolute. So let's make this absolute as well, and then I can drag this down. Perfect. So if you just take a look here at the difference in formulas versus this, just a different function. Okay, so the z-score, in this case, where they're asking us for actual z-scores for these following values. So what I would do here, I found the z-scores for the actual values herein. If I wanted to actually see what a score of 16 would be, you could essentially create another array of these values. That's what I would probably do. So 16, 7, 19, and 9. And I'm going to do the same exact thing that I did before. In this case, I'll just use the standardize function. And the x value is going to be this 16. The mean, let's reference that absolutely, and the standard deviation, absolutely, and drag it down. So these give us the answers that we are looking for. 1.42. Negative 0.5, in this case, 60. 18, 2.19, and for z, negative 0.05. Oops, sorry. Great. Okay. I've gotten out of the habit of labeling these worksheets, but you should be labeling them correctly. Okay, let's copy this to the clipboard. This is an example of group data where we are going to have to find the, looks like the mean and the standard deviation. Okay. So the first thing we have to do here, because it's group data, is make sure that we have an appropriate x value to multiply by the frequencies. And what we're going to do here is take the midpoint. So a value that falls between 0 and 2 is going to be 1, between 2 and 4, 3, so on and so forth. So this is the x value that we're going to be using, and it's the midpoint. You can actually just grab it by the median. It's the same as taking the median value between 0 and 2. Okay. So what we're going to do here is, again, multiply x by the frequency of x. And if you recall from before, we're going to sum this up. And we have to sum up these frequencies as well. And you're going to then divide. So in this case it's 5.4. And the standard deviation is going to be each of the x values minus the mean multiplied, I think, let me think about this. So what I need to do here is multiply this all. So equals each of the x's minus x bar, let's make that absolute, square it, and then multiply it by the frequency. Make sure the only thing that you have absolute here is the reference to the mean. You can drag this down, and this, recall, is our variance. So the standard deviation squared is the same as the variance. So what we have to end up doing here is summing these values. That's what we're getting in our denominator. So sum of these values, that's our, our numerator. Now our denominator is going to be the sum of the frequencies minus 1. So equals this minus 1. And then this is going to give us our variance. And how do we get our standard deviation? We take the square root of the variance. So in this case, 2.051 is our standard deviation for grouped sample data. Okay, let me put this here. Following data sets, copy these to the clipboard. Percentiles sometimes are a little funny in Excel because there's a couple different formulas that you can use. And we've got, they're asking us for the 15th percentile. So equals percentile, the array here, and it's asking us for, oops, forgot to put my 0.15. This is going to be 13.4. It's actually saying for us not to round, so it's actually being explicit there, giving us the decimal place. In this case, I can just change these values. So the 35th percentile is going to be 0.35. That's giving me 19. The 65th percentile, I'm just going to go back into this formula and change it to the 65th percentile. That's giving me a value of 28.4. And let's check that last answer. Great. Now here it's asking me for the percentile rank. I want to go ahead and take this one out of the homework. So you're not going to see this on yours. Just because I've taken it out of the quiz and everything. I forgot to take it out of the homework. So you actually are only going to have 10 questions in your homework 3 once this episode is aired. Okay, well, last but not least then, let's copy this. This actually isn't going to be the last one, I just realized. Alright, so we've got our first, second, and third quartiles. Quartiles, again, are the same as percentiles. So what we can do here is equal percentile, inclusive. I think they also give us a quartile one, yeah. So quartile, the array here. Now watch this, it's asking me which quartile I'm interested in. So for the first quartile, we just put in the formula 1, and that's going to tell us this 36. If I go in and put 2 in, the value is going to be 57.5. And for the third quartile, 78.75. 78.75. Alright, let's check this answer. Always love it when they tell me fantastic. An interquartile range is simply going to be the third quartile minus the first quartile. So just 78.75 minus 36. 42.75. Okay. At first I thought it said wow. Wow! You did it! Alright. This will be the last one, and again, because you're only going to have 10 here, I'm going to take out that percentile rank one. Alright. Here, we're going to calculate the covariance between these two sample data sets. So covariance equals S, array 1, doesn't matter which array you choose first. Really X is predicting Y usually, but in correlation we can never say anything is causing anything. So this sample covariance is negative, meaning that as one goes up, the other goes down. Let me just show you visually what this looks like. We're going to get into this a little bit next time. This is a little bit funny, but it looks like it's tending to kind of go down here. It's almost quadratic. The sample correlation, actually, you could do this a couple different ways. You could just ask for the correlation, but you could also grab the standard deviation for each of these. So I'm going to actually do that really quickly. Standard deviation of each of these samples here. And the correlation you can get a couple different ways. It could either be the covariance divided by the product of the two standard deviations, so that would be this divided by this times this. Or you could just say equals correlation of array 1 and array 2. It's going to give you the same exact value. So here the sample covariance is this negative 1.33. Okay. And the correlation is negative 0.24. 25, sorry, so 2 decimal places. Check this answer. And because it's negative, what's happening is this inverse relationship. And as one goes up, the other goes down. So as these values tend to increase, these values tend to go down. This isn't the best example because, again, it doesn't even really look that linear. But what we would say, it's definitely not a perfect negative relationship, but it is negative. Great. All right, excellent job on homework 3. Again, you will see your items being 10 that you have to complete, as opposed to 11 that are reflected here, because I'm going to take out that percentile rank one. Okay, see you soon.